made possible by popular demand, the answers to the Chapter 8 practice test. Okay, so these are the problems that you're supposed to do, 3, 4, and 9 through 27 odd. So we're going to start with number 3. You need to find the domain, range, and increasing intervals, decreasing, so forth. So let's first go over so possible roots, right, are the roots of 4, so plus or minus 1, plus or minus 2, plus or minus of the code ending 4, and then this number divided by 2. So 4 over 2 is 2, 2 over 2 is 1, and then 1 over 2, so that's the additional one. Okay, so let's try 2. So using synthetic division, you have 2, negative 9, 12, and negative 4. Bring down the 2. 2 times 2 is 4. Add negative 5. 2 times negative 5 is negative 10. Add, you get 2. And 2 times 2 is 4. Add, and you get 0. So this does factor to x minus 2, because this root means it has this factor. And then the leftover is 2x squared minus 5x plus 2. And then we can factor that using a mini area model diamond. Let me just zoom in for a second. So put 2x squared here, 2 here, multiply them, you get 4x squared, and then you have negative 5x. So negative 4x and negative x. So then that's 2x minus 1 and x, and then minus 2. So it's x minus 2, and then 2x minus 1, x minus 2. So because this, so we have a 0 at 2, so you have an x-intercept at 2, 0, right, which we found right away, and then another one, sorry, let me zoom out, another one at 1/2 from here. So right there. And then it bounces, since the multiplicity of this 2, there's 2 factors of x minus 2, so, and that's an even, so it bounces at 2. And then it's a cubed, so it starts down here, comes up, then bounces, and then goes like this. So our domain is all real numbers, and our range is all real numbers. Our y-intercept is always your constant, so your y-intercept is 0, negative 4, which I should probably plot instead of just, so there we go. And increasing intervals, your increasing intervals are when you're going up, so like here and then here. And then your decreasing intervals are when you're going down, so like here. So then you just say like from where to where. And then your end behavior, you want to say as you go to the right and as you go to the left. So as you go to the right, so if you trace your finger to the right, you go up, so y goes infinity. And as you go to the left, right, as you trace your finger, y goes to negative infinity. Now to find like where this hump is, you have to use your calculator. You know one increasing interval starts here at this x-intercept from like x is greater than 2. it happens. And then also when it's less than whatever this value is. So you need to find that hump. So you want to graph that. So 2x cubed minus 9x squared plus 12x minus 4. So there's that. You graph it. So just like I said, here it intercepts at 1/2 and then bounces there. So you need to find what this max is. So you go to calc and then you max, and then you go a little to the left of the hump, press enter, a little to the right of the hump, press enter, and then there. So the max is 1, 1. So then this point, should adjust my, ew. Quite ugly. Okay, anyways. Let's just make it worse. So 1/2, 4, 1, 1 there. So okay. So then it's increasing when x is less than 1, and then it's decreasing from 1 to 2. So there you go. Now this one here, this factors, you can factor it by grouping. Because if you take out a negative x cubed here, then you have x minus 3. And then here you take out an x. You have x minus 3. So then that's negative x cubed plus x. And then x minus 3. And then that factors more. You can take out a negative x. And you get x squared minus 1. And x minus 3. And then that factors even more to x plus 1, x minus 1, x minus 3, since that's a difference of squares. Okay, so then we have 4 zeros. You add the 0 from the negative x, negative 1 here, positive 1, and positive 3. So let's write that all here. So x-intercept 0, 0, negative 1, 0, 1, 0, 3, 0. And then our y-intercept is 0, 0. And then the domain, so since this is a negative leading coefficient, that means it's the end behavior is going to be down, down. Like, remember, the even ones, they go the same direction. They're either both like this or both like this. The odds go in like opposite directions, right? It's either like that or like that, right? And then the evens are this or like this. So since it's negative, they're both facing down. So it's y goes to negative infinity for both. So it's going to come up, and then none of these, all the multiplicities for these are odd, so it crosses every time. So it goes up, comes back down, crosses, then goes back down again. So that's kind of like the general shape. So increasing would be like here and here, right? And decreasing would be here and here. And instead of like making the mistake of highlighting again, I'm just gonna go ahead and graph it now. So if I go to y equals, right, and type this in, so negative x to the 4th plus 3x cubed plus x squared minus 3x. Okay, so we'll go ahead and graph it. So it should come through -1, then go back down to 0, back up 1, back down to 3. Oh, see, I generally had the right shape. So then now I just need to find what these hills and valley points are. So we're going to calc, and then we're going to do the maximum. So let's find this first one here. So -0.6. So it's increasing when it's less than -0.607. So right here. And then now we need to find this valley. So we'll find this minimum. So this low point 0.53. So it's decreasing from here from -0.607 to 0.530. Let me draw it with a thing. So this is here when it's going up, and then this one is this between those x values. And then now we need to do, this is an increase interval, so that's going to start at 0.530, and then we just need to find what that hill is there. So we calculate the max again. So 2.36, so 2.326. So then and then the last decreasing interval is x is greater than 2.3 or 326. Okay, so this increasing interval is like here, and then this decreasing interval is here. So there you have it. Alright, so let's move on to 9. So skip this page. So 9 says, given the graph of the polynomial function to the left, determine the sign of the leading coefficient and whether the function has an even or odd degree. So, because they're both going the same direction, it's even, and since they're both going down, it's negative leading coefficient. Alright, so it says divide the polynomial. So for these ones you have to use the long division. So it's 4, so x squared plus 2x minus 3, and then it's 4x cubed plus, oops, so it's only doing odd, JK. So 6x minus 3 Okay, so since it skips the zeros, right, the x squared, you have to put 0x squared minus 6x plus 2. Okay, so 6x times what is 24x cubed? 4x squared, so we put that here. Then 4x squared times 6x is 24x cubed, and then 4x squared times negative 3 is negative 12x squared. And then we subtract them, and then subtracting becomes positive 12x squared. And then 6x times what is 12x squared? 2x. So then 2x times, we need to bring down the negative 6x. So 2x times 6x is 12x squared. And then 2x times negative 3 is negative 6x. And then you subtract them, and they both go away. And then you bring down the 2. And then you have 0. And then that's 0. So you have a remainder of 2. So the answer is 4x squared plus 2x with your remainder over what you were dividing by. Okay. Now it says use the remainder theorem to evaluate f of x at x equals c. So you can plug this in using synthetic division. So 2 and then 1 negative, you have to put a 0 in for the cube term. So 0, negative 5, negative 17, 15. And then whatever is the last number is the answer. So bring down the 1. 1 times 2 is 2. You add, that's 2. 2 times 2 is 4. You add, that's negative 1. Negative 1 times 2 is negative 2. You add, and you get negative 19. 2 times negative 19 is negative 38. And then you add, and you get negative 23. So the answer is negative 23. So this is what f of 2 is, the last number. Okay, let's move on to 15. It says use the rational zero theorem to list all possible rational zeros. Okay, so remember, it's this number over this, factors of this number over factors of this. So since this is just 1, it's all the factors of this over 1. So 30 has plus or minus 1, plus or minus 2, plus or minus 3. It's not divisible by 4, but it's divisible by 5, divisible by 6, then 10, 15, and then 30. Okay, so use Descartes' rule to give the possible number of positive and negative real zeros. So I didn't go over this, I apologize, but for your information, Descartes' rule depends on sign changes. So if you can see for the between the terms, so this term's negative, this term's positive, that term's negative, that term's positive, and that term's negative. So you want to look at like sign changes. So if it changes to positive or to negative, it's a sign change. If it changed from negative to positive, it's a sign change. So it goes negative to positive, so that's a sign change. Now it goes positive to negative, so that's another sign change. And then negative to positive, that's another sign change. And then positive and negative, that's another sign change. So there are 4 sign changes. And then the rule says that the positive real numbers are the up to the amount of sign changes, and then if you count down by 2, so 2 and then 0. Okay, the negative real zeros are the sign changes if you change all the numbers. So if you rewrite this as x to the 4th minus 2x cubed plus x squared minus 9x plus 1, and then you look at the sign changes there. So sign change here, sign change here, sign change here. and then sign change here. So then there's also 4 sign changes, so then 4, 2, and 0. Okay, so here it says find all the zeros and give the complete factorization of the function. Use the rational zero theorem in division when necessary. Simplify all irrational and complex solutions. Okay, so for this one, we're going to list the possible roots. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So we want to test those out. So like I said, use your graphing calculator to kind of like minimize the amount of guessing and checking that you have to do. So for instance, like -1 should work. Oops. So then your coefficients is 1 for the x cubed, 0 for the x squared, -13 for the x, and then -12. Alright, so bring this down, you get 1 times -1 is -1, add, you get -1, -1 times -1 is 1, add, you get -12, -1 times -12 is 12, add, you get 0. So then, since x -1 is a 0, then x plus 1 is a factor. So then f of x factors to x plus 1, and then x squared minus x minus 12. So that's from here, right? And then you can factor the rest of this. So the complete factorization, right? This factors to x minus 4 and x plus 3. So our zeros are -1, 4, and -3. And you can see they were listed here. There's -1s here, 4, and 3. And remember, it's an x cubed, so we can have up to 3 zeros, and we do. Okay, let's try this one. So, factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. And then it's all of these over possible fact of 3. So then it's also plus or minus 1/3, 2/3, 4/3, 5/3, 10/3, getting real ugly over here, 20/3. Okay, so oh, oops, forget what I said. I didn't realize that is not the constant, right? That's -20x, so constant is 0. So first then you need to factor out an x from everything. So that's 3x cubed plus 11x squared minus 24x minus 20. Okay, now you can list the factors. So they are the same as what I basically said, because now that is the constant. Okay, so you again use your graphing calculator as a guide to minimize again the amount of guessing and checking. So look at your x-intercepts on your graph. Okay, so 2 should work. So we'll factor this part. So then 3, 11, -24, and -20. So bring down the 3 times 2 is 6. Add that's 17 times 2 is 34. Add that's 10 times 2 is 20. Add that's 0. So if 2 is a 0, then x minus 2 is a factor. So then this keeps going to x times x minus 2. and then this 3x squared plus 17x plus 10. And then we can use like our area model and diamond. So then that's 3x squared here, 10 here, 30x squared, 17x. So that's 15x and 2x. So that's 3x x plus 2 plus 5. So our complete factorization is x times x minus 2 times x plus 5 times 3x plus 2. So our zeros are 0 from here, 2 from the second factor, and then negative 5, and then negative 2/3. Okay, moving on to 23. So, again, use your graphing calculator to help you find an initial 0, like a jumping off point. So 3 should work. So then that's 1, negative 3, 12, negative 36. So bring down the 1, times 3 is 3, add, you get 0, times 3 is 0, add, you get 12, times 3 is 36, add, you get 0. So since we got 0 there, this works, right? And then, so then if 3 is a factor, then or a 0, then x plus minus 3 is a factor. So this factor is to x minus 3, and then this factor is to x squared plus 12. And then this doesn't factor, so to find our complete factorization is x minus 3 and then x squared plus 12. This has imaginary answers, so you want to solve it. Set n equal to 0, subtract 12, square root both sides, and you get plus or minus root negative 12, which is plus or minus, and then that's root negative 4 and negative 3. So that's 2i root 3. So our zeros are 3 and plus or minus 2i root 3. Right, so there are three roots. And remember, imaginary roots aren't x-intercept, so only this one is the x-intercept. Okay, let's, here, 25. List the zeros of the function below, state their multiplicities, and describe the effect the multiplicity has on the graph by indicating whether the function intersects or is tangent to the x-axis at that point. So the zeros come from the different factors. So 0 for x to the 4th is 0. X minus 2 to the 7th has 2. And then this has 1/4. So this was a common mistake on the quiz, right? This doesn't have a 0 of 4, right? Or 1. You set that equals 0, and then it has a 0 of 1/4. And then this has a 0, last one, of negative 5. And then their multiplicity are their powers. So this is to the 4th. This one's to the 7th, this one's to the 3rd, and this one's to the 1st. And then depending on whether the multiplicity is odd or even tells you if it bounces or not. And bounces just means the tangent. And then crosses is intersect. So we'll just use the ones we used before. So this bounces because it's even, and the rest crosses because they're odd. Okay, last problem. It says use the zeros to write a polynomial function. So your y, you want to use if 5i is a 0, then so is negative 5i, right? Remember, they always come in conjugate pairs. So it's, and then to get 5i, right, it's x squared plus 25. And then this one, x, plus or minus 2 root 3. So it's plus 2 root 3 minus 2 root 3. So you want to expand this. So use an area model. So x plus 2 root 3, x minus 2 root 3. This will give you negative, this is x squared. This will give you 2 root 3x and negative 2 root 3x, which will cancel. And then this 2 times negative 2 is negative 4, and root 3 times root 3 is 3. So it'll be negative 4 times 3, which would be negative 12. So this is x squared plus 25 times x squared minus 12. And then you need to do another area model. So you can write out the whole thing in standard form. So that's x to the 4th. Then that's negative 12x squared. That's 25x squared. And then 25 times 12 is 300. So then it's x squared, x to the 4th plus 13x squared plus 300. Alright, that's it. Thank you for watching. Have a nice day.